The National Electrical Code, or NEC, does not contain a rule that specifically prohibits the use of number 14 American wire gauge, or AUG, conductors for 15-amp branch circuits. This means that according to the NEC, it is generally permissible to use number 14 AWG wire on a 15-amp circuit, assuming all other requirements are met. However, it is crucial to understand that the NEC is not the only set of rules governing electrical installations. Local jurisdictions, such as cities, counties, or states, often adopt the NEC as a baseline but may also introduce their own amendments, additions, or more stringent requirements. These local rules are legally binding within their respective jurisdictions and take precedence over the NEC. In the scenario presented, the electrical inspector is likely enforcing a local rule that prohibits the use of number 14 AWG conductors for 15-amp branch circuits. This is a common practice, as local jurisdictions may have specific reasons for implementing stricter standards. For example, they may want to enhance safety, improve the reliability of electrical systems, or address specific environmental conditions or infrastructure limitations within their area. To determine the specific local rule that the inspector is enforcing, it is necessary to consult the electrical code adopted by the local jurisdiction. This code can typically be obtained from the local government's building department, electrical inspector's office, or online. It is essential to carefully review the local code to understand the specific requirements for wire size, circuit protection, and other electrical installations. Now let's delve into the factors that influence wire size selection in electrical circuits. The NEC provides guidelines for determining the appropriate wire size for various applications, taking into account factors such as the ampacity of the wire, the overcurrent protection device, the length of the circuit, and the voltage drop. Ampacity refers to the maximum current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The NEC publishes ampacity tables that list the allowable ampacities of different wire sizes based on their insulation type and installation conditions. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating and potential fire hazards caused by excessive current flow. The NEC requires that the overcurrent protection device be sized to protect the conductor. In general, the ampacity of the conductor must be equal to or greater than the rating of the overcurrent protection device. However, there are some exceptions to this rule, such as when the conductor is part of a motor circuit or multi-outlet branch circuit. The length of the circuit is another important factor to consider when selecting wire size. As current flows through a conductor, it experiences a voltage drop due to the resistance of the wire. The longer the circuit, the greater the voltage drop. Excessive voltage drop can cause equipment to malfunction or operate efficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To minimize voltage drop, it may be necessary to increase the wire size. Voltage drop is calculated using Ohm's law and the wire's resistance per unit length, which can be found in NEC tables. The formula for voltage drop is volts drop equals 2 times length times current times resistance per unit length, divided by 1000. The NEC provides tables and formulas to help determine the appropriate wire size for different voltage drop requirements. In addition to ampacity and voltage drop, other factors may also influence wire size selection. These factors include the type of load being served, the ambient temperature, the presence of multiple conductors in a raceway, and the type of insulation used on the conductors. For example, circuits that serve motors or other inductive loads may require larger conductors to handle the inrush current that occurs when the motor starts. Similarly, circuits that are installed in high ambient temperatures may require dilating the ampacity of the conductors to prevent overheating. The NEC provides specific guidelines for dilating conductors based on ambient temperature and the number of conductors in a raceway. When multiple conductors are installed in a raceway or cable, the heat generated by each conductor can raise the temperature of the other conductors. To account for this, the NEC requires that the ampacity of the conductors be dilated based on the number of current-carrying conductors in the raceway or cable. The type of insulation used on the conductors also affects their ampacity. Some insulation types are rated for higher temperatures than others. Conductors with higher temperature ratings can carry more current without exceeding their temperature limits. Now, let's discuss the specific requirements for branch circuits that serve receptacles. The NEC defines a branch circuit as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlet. Branch circuits are typically classified based on the ampacity of the overcurrent protection device. For example, a 15 amp branch circuit is protected by a 15 amp circuit breaker or fuse, while a 20 amp branch circuit is protected by a 20 amp circuit breaker or fuse. The NEC specifies the types of receptacles that are permitted on different ampacity branch circuits. For example, 15 amp receptacles are permitted on 15 amp and 20 amp branch circuits, while 20 amp receptacles are only permitted on 20 amp branch circuits. This is to prevent overloading the circuit by plugging in too many devices. The NEC also specifies the maximum number of outlets that are permitted on a branch circuit. The maximum number of outlets depends on the type of load being served and the ampacity of the circuit. For general-purpose receptacle circuits, the NEC typically allows a maximum of 12 outlets on a 15 amp circuit and 15 outlets on a 20 amp circuit. However, this may vary depending on local codes and the specific application. In the scenario described, the tanning salon owner installed number 14 AWG conductors for convenience receptacle branch circuits protected by 15 amp breakers. While this may be permitted under the NEC, the local inspector is requiring them to replace the wiring with number 12 AWG conductors. This is likely due to a local rule that prohibits the use of number 14 AWG conductors for this purpose. It is important to note that the 180 volt amps rule, which limits the load on a branch circuit to 180 volt amps per outlet, does not override the requirement for proper wire size. Even if the load on each outlet is less than 180 volt amps, the wire size must still be sufficient to carry the total current of the circuit without exceeding its ampacity or causing excessive voltage drop. To ensure compliance with electrical codes, it is always best to consult with a qualified electrician or electrical inspector before starting any electrical work. They can provide guidance on the specific requirements for your location and application. Remember, electrical work can be dangerous if not performed properly. It is important to follow all safety precautions and to obtain any necessary permits before starting any electrical project. The information provided in this explanation is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work. Firstly, always prioritize safety when working with electricity. Secondly, familiarize yourself with the NEC and local electrical codes. Thirdly, select the appropriate wire size for the application. Fourthly, use overcurrent protection devices to protect conductors. Fifthly, limit voltage drop to ensure proper equipment operation. Sixthly, consult with a qualified electrician or electrical inspector if you have any questions or concerns. Now, let's consider some additional factors that can affect wire size selection. One factor is the ambient temperature. The ampacity of a conductor decreases as the ambient temperature increases. This is because the conductor generates more heat at higher temperatures, which reduces its ability to dissipate heat. The NEC provides tables that list the ampacity correction factors for different ambient temperatures. To determine the corrected ampacity of a conductor, multiply its ampacity by the correction factor. For example, if a number 14 AWG conductor has an ampacity of 15 amps at an ambient temperature of 30 degrees Celsius and the ambient temperature is 40 degrees Celsius, the correction factor is 0.82. The corrected ampacity of the conductor is therefore 15 amps times 0.82, which equals 12.3 amps. Another factor that can affect wire size selection is the presence of multiple conductors in a raceway or cable. When multiple conductors are installed in a raceway or cable, the heat generated by each conductor can raise the temperature of the other conductors. To account for this, the NEC requires that the ampacity of the conductors be derated based on the number of current-carrying conductors in the raceway or cable. The NEC provides tables that list the ampacity adjustment factors for different numbers of current carrying conductors. To determine the adjusted ampacity of a conductor, multiply its ampacity by the adjustment factor. For example, if a number 14 AWG conductor has an ampacity of 15 amps and there are 4 current carrying conductors in the raceway, the adjustment factor is 0.8. The adjusted ampacity of the conductor is therefore 15 amps times 0.8, which equals 12 amps. The type of insulation used on the conductors also affects their ampacity. Some insulation types are rated for higher temperatures than others. Conductors with high temperature ratings can carry more current without exceeding their temperature limits. The NEC provides tables that list the allowable ampacities of different wire sizes based on their insulation type. For example, a number 14 AWG conductor with type THHN insulation has an ampacity of 20 amps, while a number 14 AWG conductor with type TW insulation has an ampacity of 15 amps. When selecting wire size, it is important to consider all of these factors to ensure that the conductors are properly sized to carry the load and protect the circuit from overheating. It is also important to follow all applicable codes and regulations to ensure that the electrical installation is safe and compliant. In addition to the factors discussed above, there are other considerations that may influence wire size selection. These include the type of load being served, the length of the circuit, and the presence of any special conditions. For example, circuits that serve motors or other inductive loads may require larger conductors to handle the inrush current that occurs when the motor starts. The length of the circuit can also affect wire size selection. Longer circuits require larger conductors to minimize voltage drop. Special conditions, such as exposure to corrosive environments or extreme temperatures, may also require the use of special types of conductors. It is important to carefully consider all of these factors when selecting wire size to ensure that the electrical installation is safe, reliable, and compliant. Remember to consult with a qualified electrician or electrical inspector if you have any questions or concerns. They can provide guidance on the specific requirements for your location and application. Electrical work can be dangerous if not performed properly. It is important to follow all safety precautions and to obtain any necessary permits before starting any electrical project. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical inspector before performing any electrical work.